SQL, or Structured Query Language, is a specialized language designed for managing and manipulating relational databases. It operates using a well-defined syntax, comprising specific statements and rules that ensure effective data operations. In this module, we will delve into the fundamental aspects of SQL syntax, exploring its structure, key statements, and the rules that govern its usage. This will help you to write effective and efficient queries. Let's examine a basic SQL statement example. Consider the code snippet displayed on the left. Here you can observe the fundamental structure of an SQL query. SQL statements are composed of clauses, which are distinct components that perform specific functions. Some of the most common clauses include select, which specifies the columns you want to retrieve from, which indicates the table you are querying, where, which filters the rows based on a specified condition, order by, which sorts the result set, and limit, which restricts the number of rows returned. SQL also utilizes keywords. These are reserved words that have specific meanings in SQL syntax and cannot be used as identifiers, such as table or column names. Examples of keywords include select, from, where, and many more. Finally, most SQL systems require that each statement ends with a statement terminator, typically a semicolon, to mark the end of a command. Adhering to this basic structure is crucial for writing valid and effective SQL queries. Data Query Language, or DQL, is a subset of SQL specifically used for retrieving data from a database. The primary command in DQL is the select statement. Look at the first code block. The select statement is used to query and retrieve specific data from one or more tables. You specify the columns you want to retrieve after the select keyword, followed by the table name in the from clause. Additional clauses like where, group by, having, order by, limit, and offset allow you to filter, group, and sort the data. Another code block represents join operations. Joins are used to combine rows from two or more tables based on a related column between them. There are various types of joins, including inner join, left join, right join, and full outer join, each serving different purposes depending on the desired outcome. The third code block represents subqueries. A subquery is a query nested inside another query. It is used to return data that will be used by the main query. Subqueries can be used in the select, from, or where clauses of a SQL statement. The final code block represents aggregate functions. Aggregate functions perform calculations on a set of values to return a single value. Common aggregate functions include count, sum, avg, min, and max. These functions are often used with the group by clause to perform calculations on groups of rows. Data Manipulation Language, or DML, is a set of SQL commands used to modify data in a database. These commands include insert, update, and delete. Let's explore the syntax and purpose of each of these commands. The insert statement, as shown in the first code block, adds new rows of data to a table. You specify the table name, followed by the columns you want to insert data into, and then provide the values for each column. The update statement, as shown in the second code block, modifies existing data in a table. You specify the table name, followed by the columns you want to update, and then provide the new values for each column. The where clause is used to specify which rows should be updated. The delete statement, as shown in the third code block, removes rows from a table based on specified conditions. You specify the table name, followed by the where clause to specify which rows should be deleted. The last code block represents insert multi-row syntax. This is useful when you need to insert multiple rows of data into a table at once. It is more efficient than using multiple insert statements. Data Definition Language, or DDL, is a set of SQL commands used to define and manage the structure of a database. These commands include create, alter, drop, and truncate. Let's explore the syntax and purpose of each of these commands. The create table statement, as shown in the first code block, creates a new table with columns and constraints. You specify the table name, followed by the column names and their data types. You can also specify constraints such as primary key, foreign key, and not null. The alter table statement, as shown in the second code block, modifies an existing table structure. You can add new columns, modify existing columns, or drop columns. The drop statement, as shown in the third code block, removes a database object completely. This can be a table, a view, or an entire database. The truncate statement, as shown in the fourth code block, quickly removes all records from a table, but keeps the table structure intact. Unlike delete, it cannot use a where clause and typically resets auto-increment counters. Data Control Language, or DCL, is a set of SQL commands used to manage database access and permissions. These commands include grant and revoke. Let's explore the syntax and purpose of each of these commands. The grant statement, as shown in the first code block, provides specific privileges to users or roles on database objects. You specify the privileges you want to grant, followed by the database object, and then the user or role you want to grant the privileges to. The revoke statement, as shown in the second code block, removes previously granted privileges from users or roles. You specify the privileges you want to revoke, followed by the database object, and then the user or role you want to revoke the privileges from. Data control language statements are crucial for database security, allowing administrators to control who can access data and what operations they can perform. This helps protect sensitive information and maintain data integrity. You can also create new users and roles in the database, as shown in the code block on the top right. This allows you to manage permissions more effectively. The code block in the middle right shows some of the common privileges that can be granted or revoked. These include select, insert, update, delete, create, alter, drop, and all privileges. The with grant option clause, as shown in the code block on the bottom right, allows a user to grant their privileges to other users. This is useful for delegating administrative tasks. Transaction Control Language, or TCL, is a set of SQL commands used to manage database transactions. These commands include begin transaction, commit, rollback, and save point. Let's explore the syntax and purpose of each of these commands. Begin transaction or start transaction marks the beginning of a transaction. All SQL statements executed after this command will be treated as part of the same transaction. The commit command saves all changes made during the transaction to the database. The rollback command cancels all changes made during the transaction and reverts the database to its previous state. The save point command creates a save point within a transaction. This allows you to roll back to a specific point in the transaction without canceling the entire transaction. The code block on the right shows a complete transaction example. This example demonstrates how to begin a transaction, update data, create a save point, insert data, and then commit the transaction. It also shows how to roll back to a save point or cancel the entire transaction in case of an error. Transactions have 4 key properties, often referred to as ACID properties. Atomicity, which means that all operations complete successfully or none do. Consistency, which means that the database remains in a valid state before and after the transaction. Isolation, which means that transactions are independent of each other. Durability, which means that committed changes are permanent. Operators and expressions are fundamental components of SQL that allow you to build conditions and perform calculations in your queries. SQL provides a variety of operators, including comparison operators, logical operators, special operators, and arithmetic operators. Comparison operators, as shown in the first code block, are used to compare values. These operators include equal to, not equal to, less than, greater than, less than or equal to, and greater than or equal to. Logical operators, as shown in the second code block, are used to combine multiple conditions. These operators include and or and not. Special operators, as shown in the third code block, are used to perform specific tasks. These operators include between and like is, null, and exists. Arithmetic operators, as shown in the fourth code block, are used to perform basic arithmetic calculations. These operators include addition, subtraction, multiplication, division, and modulo. SQL constraints are rules that enforce data integrity in a database. They are used to ensure that the data in a table is accurate and reliable. Let's explore the different types of constraints and how they are used. Primary key constraint uniquely identifies each record in a table. It cannot contain null values and must be unique. Foreign key constraint links data between tables, maintaining referential integrity. It prevents actions that would destroy relationships. Not null constraint ensures a column cannot have a null value. It forces entries to have a value, improving data completeness. Unique constraint ensures all values in a column are distinct. Unlike primary key, it allows one null value. Check constraint ensures all values in a column satisfy a specific condition. It is used to enforce business rules on column values. Default constraint sets a default value for a column when no value is specified during an insert operation. You can also name constraints for easier management. This is done using the alter table statement, as shown in the example block. Writing efficient and maintainable SQL code is crucial for building robust and scalable applications. Here are some best practices to follow. Use consistent formatting to keep SQL code readable with consistent indentation, capitalization of keywords, and line breaks for clauses. Be specific with select. Avoid using select asterisk, and instead specify only the columns you need to improve performance and reduce network traffic. Use appropriate indexes. Create indexes on columns used in join, where, and order by clauses to drastically improve query performance. Use table aliases. When joining multiple tables, use meaningful aliases to make the SQL more readable and concise. Comment your SQL. Add comments to complex queries explaining the purpose, logic, and any non-obvious parts for easier maintenance. The examples on the right side show how to apply these best practices in practice. By following these best practices, you can write SQL code that is efficient, maintainable, and easy to understand. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.